we have quite a number of things to touch today. So I'm going to share my screen so we can just simply, just go back to where we started. We'll do a little recap and then we can move forward. Oh no. All right, let me get that quickly. All right, I'm trying to pull up the screen. There you go. Okay. All right, please confirm that you can see my screen. I'm trying to pull the file we had earlier. Can you see my screen?
Not yet. Not yet.
Why is it?
Okay, yeah, I can see your screen now. I can see your screen.
Ah, okay. Why is this showing? Okay, I'm trying to pull up the slide from earlier so we can quickly do a recap. But who here remembers some of the things we talked about while we are trying to pull the file? Who remembers? Anyone remembers anything at all? Anything? Anybody? Remember any of the things we spoke about? Now would be a time to share. Anybody? Going once? Anyone hear me? All right, so let's proceed. I would like to hear feedback. If once I say something, I'd like to hear that people are here. Just unmute your mic and speak. Okay, so very quickly, we have quite a number of things to cover today. I hope we have the time. This is the last class we had. We introduced microservices. We talked about what it is, how to achieve what's important, the kind of things you should do by the time you are thinking about starting or breaking the monolith into a microservice. We talked about why it is important. We talked about some of the pros and cons. We talked about all these other things, how it helps with service independence, how it enhances scalability. We also mentioned the fact that I'm so sorry, Daniel, is this class recorded?
Yes, it is.
All right, okay. So we also mentioned the fact that microservices as a whole is a component of, it's a branch of distributed computing, right? We spoke about how it allows you to use different, technology for different services depending on what they need to do. We talked about why it encourages the DevOps culture because of the complexity of pushing and continuously developing and integrating all the services at a time. About some things. Who remembers? Anyone remember? Does anyone remember? Might not be the time to talk. Like, who remembers? Anything?
Sorry, I didn't get you at some point. Remember what?
That's one of the things we talk about.
Okay, I think there was a time you mentioned you gave an instance of Jumia, for
Daniel, not
instance.
you. Daniel, not you. Daniel, not you. Any
Okay,
other person?
okay.
Any other person? Maybe we were in this class the last time. Okay. All right, let's move forward. We talked about how, because of the independence of the services, you can implement security separately. So the last thing we spoke about was the several patterns. Now, microservices as a whole has different ways of implementing them. They are external, right? This was the 5 we spoke about. The API gateway, we have a central service in front of all the other services that receive requests and routes the requests to the different services based on the request, based on the URL. This API gateway also serves as a circuit breaker in some cases. It helps with authentication and authorization. It helps with this kind of things. The circuit breaker pattern, the event-driven pattern, the saga pattern. Okay, so let's go back to the diagrams, right? Okay. So that we know that. All right. So this is the API gateway, right? The API gateway is the central service that sits in front of the services. It receives the request from the clients and then routes it, right? That's its job. So let's quickly read this. If we it already needs also, it has it does the monitoring because it sees all the requests. Okay, so database pattern is the pattern where database service is the pattern where every service has its own database, right? Depending on the business requirement and depending on the available resources in the company, in the organization, each service can have its own database. Ideally, that's what it is. But in some cases, if the database you're using is paid for, some of these document databases that are charged per document, right? It may not be feasible to have each service have its own database, right? In some cases, you can have different services sharing the same database cluster. That may be tricky, but it's achievable. The next pattern is circuit breaker pattern. We spoke about this pattern. You can prevent a network or service failure from getting to other services when the circuit breaker trips and prevents further calls to the failing service. It then periodically ends to call the service and it closes the circuit breaker pattern was derived from electronics, right? You have a circuit breaker at home. If something fails, usually there's going to be a fuse, right? I don't know if you guys are familiar with fuses, little fuses that have like a slim wire, right? The fuse serves as a check. The fuse, if the fuse is 9 amps, for instance, if it sees voltage that is above 9 amps, it will trip, just to save and secure the system, right? A circuit breaker does that. If one service fails, it stops that failure from passing to other parts of your service. Event driven, this is one of my favorite. Event driven is a pattern where the action of every service is registered and sent to a message broker, and another service just listens. Another service who subscribes to that topic will listen to it and then do something. Kindly approve the request. Also, all approved. All right. Okay. Right. So very quickly, I don't know if we can go back and test what we did earlier just before we proceed. Right? Can we do that? If I get enough yeses, voice yeses, I will proceed.
Yes, you can.
Daniel, not from you. I want to hear other people speak. Can we go back? Can we go back?
Yeah, you can. You can.
Benjamin, good. Who else? Farouk. Benjamin, Tochuku, Joseph, and the others.
Yes.
Go back. Please unmute
Yes,
your mic.
Jessica.
Tochuku, unmute your mic. Please unmute your mic and speak. Ayeni, David, Junu, Farouk, Gostein, Jackson, Joseph, Richard, Time, Tochuku, Smell. Please unmute your mic and participate.
Yeah, please, you can go back for me.
Any other person?
Yes,
Or
you
again,
can.
in space that is noisy, you can raise your hand digitally and then you can just
Yeah,
do this.
Please let's go back.
Oh,
please. I
great.
joined privately.
Good. All right. So I'm just going to share my screen. All right. What you're about to see is going to be very messy. It's going to be very, very messy, but stay with me. I was working on this while preparing something else. All right. Okay. All right. Welcome to mess. All right. So this is now for the record, what we're going to look at today, we're going to look at the event-driven pattern, right? Where it's a service does something and then broadcast that event to a message somewhere, and then another service will listen, will subscribe to that topic, and then receive that event and do something as a result of what it has received. All right. So very quickly, let's do that. Let's attempt to do that. But before we do that, let's sort of go back to where we were so that we understand the difference, right? The first iteration was where if a service needed something, it will make a call, it will make a HTTP call to that service, retrieve the information, based on that information to do something. So let's quickly do that. I will go into all the services now. All right, so let's get what we have here. So comment and move on. So this is event driven architecture work in progress. I need to do this. All right. Can you guys see my screen?
Yes.
Okay. We have pushed that. Okay. So that's the next thing. CD change here. Git commit. Okay. That M flag. Well, Git. I made a mistake. If you see something on your mic, unmute your mic and say something. Does that work? Unmute your mic and then just raise your hand. I'll recognize you and then. Okay. We have another service, and that service is the service. And let me try to stop it. Git add. So git commit -m. Same thing. All right. What other service do we have? API gateway. Okay, can I have a chat, please? Okay, so this should be status API gateway discovery service. Okay. Into the API gateway. Okay. Git commit m. Okay, so let's see here. let's see. It's actually going to be okay. Push, push, push. I hope that works. Okay, so this is the same thing here. Push. It's push. It's push here as well. And it's push here as well. Now the reason we are doing this is so that we can change happen here. Oh no, okay, this is a second one. Push is working. Push what here? Everything's up to date. Everything is up to date. Everything is up to date. Everything is up to date. All right, so let's check out now. So let's check out first of all, what branch are we? I created another branch. So in case you're interested, we're in the event branch. So let's check out. Let's check out master. Switch to master. Great. All right. All right. So. Let me take this image just for real estate. Can everyone still see my screen? Please,
Yes, yes, I can see your screen.
Yeah, but your voice is breaking. I actually thought
My
it was
voice-
from my mom, actually.
Oh, I'm so sorry. I'm so sorry about that. I have MTN. I'm in Lagos, Nigeria, by the way. I have MTN. I'm not sure why. Just the class is recorded, so if you have any issues, then I'm sure you can always get back. All right. But thank you for letting me know. Okay, so let's proceed. Now, I'm going to attempt to start the service. Can you guys still hear me? Someone tried to call me.
I can hear you now. I can hear you now.
All right, okay. I'm going to attempt to start the services. I know that I have started the services. The services are still running. So for the record, we have a simple e-commerce application that has 4 services: the checkout service, the product service, the inventory service, and the user service. Okay, this is strange, but all right. The services are started. You guys can see this. So let's go through what we have. Okay. Let's start with the product service. Can you see my screen? Okay, you can see this. So let me just share my entire screen. Let me share my entire screen so you guys can see. Share my entire screen. Share screen 1. All right, screen 1 is coming up soon. Let me know when you can see my screen. There you go. My screen is coming up. Please confirm that you can see.
Yes, we can see your screen.
Yes.
Good. So let's go through the service one by one. Very quickly, we have quite a ton of things to do. The event-driven pattern is huge. So this is the product service. What does the product service do? It does one thing. Now remember, one of the advantages of the microservices pattern is that it allows for segregation of duty. So the product service just does everything that is related to the product. The checkout service just does everything that's related to the checkout. You get the point. So let's go through what the product does. Very simply, okay. So the product does this. it just adds the product just adds a product. You can update the product. You can update a product. You can get all the products. You can get a single product using the ID. You can get the product price. You can find out if a product exists by its ID. So once you give the product ID, you say, oh, yes, it exists, or no, it doesn't exist. This returns a Boolean. That's it. That's all it does, right? Okay, so let's go and add a product. I hope this thing doesn't. Okay. All right. Let's go and add a product. Someone should let me just call someone. Right. Tochukwu, please give us a product name. Tochukwu, give us a product name.
Yeah, iPhone 7.
My G iPhone 7. Is that Pro or Pro Max?
Pro Max, please.
All right. All right. Okay, iPhone 7. All right, so let's give it a quick description. iPhone 7 Pro Max. All right, and how much is that iPhone, Tochukwu?
Let's do 180K.
Nah, that one is made in a bar. I can assure you. But let's do 180. All right, so let's do that.
Yeah.
All right, so the product service just does everything related to the products. That's all. So we're just going to use this iPhone, for our okay, so a product has been created. What happens next? So the inventory, maybe the people from the admin would want to create an inventory from that product, correct? This iPhone, basically this iPhone, how many did the supplier give us? Does that make sense? Does that work? I need someone to respond to me. Anyone?
Yes. Oh,
Good. So let's get to the service and see inventory service. So we just now the admin, the shop admin, whatever we can call this Jumia or whatever, wants to add the number of iPhones that we were given. So let's go. Close this, open the inventory, open the add, all right, so the product ID, who remembers the product ID? Product ID, product service, where are you? Product ID, iPhone 7 is 31. Great. So product ID is 31. Then how many were we given? Let's say we're given Tochukwu. How many did they give us? Tochukwu.
8.
Tochukwu. Second?
8.
8. Okay, so it's available. And let's do this. Good. So now it has been added, right? We can see that. Let's even try and add it again and see what happens if, inventory, we shouldn't. Okay, so let's go to the product. Let's go to all inventories and see. All inventories. Let's see if we have our iPhone 8. Okay, there you are. Right, and we have quantities 8. All right. So very quickly, what does it do? When it is trying to create an inventory. So let's look at it. The first thing it does is that it makes a call to the product service to ask if the product ID that it has received exists. Look at it. Add inventory. Add inventory, right? We were given product ID at 31, right? The first thing it does is that it makes an external HTTP call to the product service to ask if the product ID exists. If it exists, if it returns, if it receives a success response, then it will go and check if the inventory is already created. This function does inventory already exist? This guy says yes or no. If he says no, if not, does inventory already exist? With the product ID, it will go ahead and create that. Very simple stuff, right? So what I want you guys to pay attention is the places where we have made the calls. So remember, to create an inventory, the inventory service makes a call to the product service, right? I wish anyone can write that. Good. So now that has been done. So what's the next thing? The product is now available on our front. The products have now been displayed on our landing page and everything. So now the customer is going through the products and is about to add to cart, right? Has seen this iPhone and wants to add to it, correct? I'd like a response.
Yes. Yes.
Add to cart. Good. Good. So let's go and try and add that iPhone to cart. And then once it's successful, if it is successful, then we'll go and look at the code. Now, what I want you guys to pay attention to the different places where calls were made to external services. Okay, so we're trying to add to cart now. Okay, so add to cart does this. The product ID was 31. And we want to add 3 to cart. This guy just wants to buy one thing. Please, we can get access to this source code after. Yes, you can. I'll share the repository. Yes, you can. All right. So let's add this to cart. Now remember that this what is happening here is that a customer has gone to our landing page, has seen the iPhone and likes it and has added because of using the same DB. No, good question. He's asking different services using the same database. No, the question is no. The answer to your question is no. Now please confirm that you can see my screen. This is the checkout service, inventory service, product service. Can you see checkout, inventory, product? So different services use different databases. Good question, by the way. All right, so this customer wants to buy 3, right? Now how many did we have? So let's go back to our inventory. We got, how many did we get? We got 8. All right, so let's go and create this product. Let's go and buy. So we're just going to simulate, we're just saying that, if add to cart, if someone has gotten here, they have bought the item. Maybe later on, depending, we can share us into groups and then we can join in writing, the different services. So let's add this to cart. Cart has been added successfully. Please confirm that you can see that the cart has been added. Now, for the purposes of our class, this process of adding to cart means a payment. Does that make sense? Right?
Yes.
Okay. Good. So now, Tochukwu, Jackson, Daniel, and maybe God's time. I would like to please have you unmute your mic so that I can get the response. So let's call this guy again and see if the product has been. Now, please confirm that the quantity is now 5.
Yes.
Remember that you good. So remember that you only do this after the payment has been done for this, and then the payment service will return a response to say, you can now subtract this. You cannot subtract 3 from this because I have received value. Does that make sense?
Yeah.
Yes.
You only do this after the payment is successful, right? Of course, we can't do that. We are doing it now because, of course, we're having a class. Good. So now this is successful. But let's go to the code. It's very simple. It's not difficult at all. How is it doing this? Let's go to add to cart. So let's go to the checkout service, right? The checkout service. Now pay attention. Inventory. Before we added the inventory service made a call to the product service. So now let's go to checkout. Checkout service. Let's go to the service, cat service. Okay. So let's look at add to cart. Please, I like for everyone to pay attention to these methods, add to cart, and what it is doing, right? Add to cart just does three things. It checks if the product exists. If that product exists, it will retrieve the quantity from that request. So where's our add to cart? Where's our add to cart? You see the product ID of 31, right? It first does a check. If this product ID, if the product exists, then I'll retrieve 3, the integer 3, right? So let's go to that method. Check if product exists and get quantity from request. Now, these methods are named intentionally so that when you get in here, you will not be confused. You won't wonder what the method is doing. And guys, please, if you have to write a whole sentence to explain your method name, please do it, because by the time you come back to it, you, the developer, you will not understand what happened. This has happened to me a couple of times. So this is why, in case anyone is wondering why this is as long as this. Now, what does that method do? It makes a call. It makes a call to the product service and checks if this ID, if this product exists, right? The product with the ID of 31. Remember our iPhone? If it gets a success response, if the product service says, oh yes, I have that product, it now does its thing. It retrieves the quantity, this quantity from the request. In other words, it retrieves the value 3, right? Now it does that, it gives that 3 to this man. Calculate total amount of each product in cart. So even if there were 4 or 5 products, it will do that for all of them, right? So what does this method do? This method is down here. Calculate products for each. Where is that? Calculate products. Here it is. Now, to calculate the product, what it does is that it makes another call to the product service to get the product price. Right? Once it does that, it then multiplies the product price by the requested quantity of 3. Can you see?
Yes, we can see that.
So this is where that calculation happens. Now, I hope we are following. If you're not following, please just stop me at any time and then I'll do whatever again. And then after that, I'll then calculate the total amount of the cart. So let's go to our EB and see. Let's go to our cart service, checkout service, sorry. So this is the cart. This is it. 540,000. These are the cart items. This is it. This is what we created now. 3, right? Eventually, we'll edit this thing to have the user ID so we know which user has which cart. Eventually we'll do that. But I just wanted to show that can someone verify 180 times 3? What does it give us? Is that 540? 180 times 3. Anybody? Jackson, Tochukwu, Juno?
Yeah, 540.
540. So you see that this cart item, eventually, of course, will have a user ID here. The cart item, you see the cart ID of 6, right? It references the cart here is 540. So you can see that is working. Now, but there's something else going on here. It's doing 3 things, right? It does a call first to the product service, checks if the product exists, retrieves the quantity from the request. Then it calls the inventory service. So it calls the product service twice, calls it here, product here, then calls the product here to get the price, and calls the inventory service to get the quantity. So to add to cart, the cart service calls 2 other services. It calls the product service first to verify that the product exists, and then it calls the product again to get the get the price for the product, and then calls the inventory service to get the quantity for that inventory. Does that make sense? Should I start again? The cart service does 3 calls, 2 to the product service and 1 to the inventory service. Okay, so we've seen how that works, right? We've seen how that works. Any question? Does anyone have any question?
From my end, no question.
Anybody have any question? Please, if there's anything you don't understand, just unmute your mic and speak, or drop a question or comment in the and let us proceed. Ayeni, Benjamin, Chigozie, David, Dunu, Farouk, because anything you don't understand, if you're not following, let me know. Can we proceed? You have any question?
I think we can proceed. We can proceed.
Any
can
other
proceed.
Any other one?
In a case, sorry, please, I just thought of a question now.
Yes, please.
Yeah, so in a case where a particular service, in between fails, what happens?
Good question. That is a marvelous question. Good. Now, so let's say, okay, so funny. So give us an example of the 3 services that we have here: the cart service, the inventory service, the checkout service, inventory and product. Which one?
Yes.
Yeah, example. Which one will fail?
Say the inventory service fails.
At what point, on whose end is it failing? Right? It goes down. It's not available. Yes, but at what point do we know that it was failing? Is it when the checkout was trying to reach it to get the quantity, or when
Yes,
the inventory is?
Yes, when the checkout. No, when the checkout was trying to reach it to get to get what is available.
Good question. Now, in a case when you are building a service for production, fault tolerance is one of the most, in fact, it's the most critical component of building microservices. The first thing you want to do is you want to always have a cache. So the cart service, right, the checkout service, right, that makes a call to the inventory would most likely have a cache. This is microservices in production that saves the data, everything that the inventory has, right? All the record that the inventory has. So once it makes a call, it first checks its cache to see, do I have this inventory, right? If it doesn't exist before it makes a call to the inventory service, so it will check its internal cache first, then the inventory service. Now, if the inventory service is down, it will receive that information from its cache, its own record that it had of from the last time they had an interaction. Does that make sense?
Yes, it does.
Now that's one way. Now the other way is to create a fail safe such that it would then call other services who had interacted with the inventory service. So if the cache is empty, for instance, it would make a call to other services to say, oh, the last time you spoke with this guy, how many did you have? And to compare that record with the time, right? Does that make sense?
Yes,
Let
it
me
does make
explain.
sense.
So if it goes into its cache and it doesn't see anything, right? It can call other services to say, oh, please, the last time you spoke with this guy, how many, first of all, did you see this product? Oh, the product is okay. From the last time you spoke with him, how much quantity this product have? Now remember that it will be different, right? Of course,
Yes.
customers will buy, and then it will then check maybe our recommendation service or our analytics service to see, is this product in demand? If this is a product that is always in demand. Now, if this product is always in demand, then chances are that from the quantity we got, the quantity you told me that they had the last time and now, between that time and now, it would have reduced because of that demand. Now, if this product doesn't have a lot of demand, we can say that that service will intelligently infer that, okay, if the last time you guys spoke with him, he had 20 pieces of this product, and it's been 3 days, and this product doesn't have a lot of demand, and this request needs 3, it's safe to say that it is available. Does that make sense?
Yes, yes.
Now remember, in error handling, no situation is perfect. You are just trying to ensure that your system is safe, number one, and if it's about to fail, it fails gracefully. Does that make sense?
Yes,
It's a brilliant
yes, it does
question.
make sense.
Funny, so we are going to come back to it. Any other question? Any other question? You guys are going
Yes.
to
I have
Yes.
a follow-up question.
Yes, please.
If he eventually finds all of this and then he still cannot get like a good record, is it safe to say you can just return like an error, like an error, maybe contact the developer or something?
No. So now remember that this is a brilliant point. Now, so you're not returning an error to the developer. It's returning an error to
The
client.
user. Yes.
Good. So the user now is not the web application or mobile. The user is the other service that is calling it.
Yes. But for that event is triggered from a client, which is like the user. Do you understand? The only reason why we can spot this error is because someone decided to go to their checkout. Yes. So I'm saying like if we explore this option, checking catch, checking other people that have other services that interacted with the is it now okay at that point, since you cannot exactly retrieve it, to maybe return an error?
Good. No. Good question. This is a brilliant question. So guess what, right? Remember that we are in a business. So let's say we are everyone in this call now, we are we are all the developers on the team. Okay. So there's 3 of us, 3 or 4 people for each service, right? As per business requirement, we will never return an error to the client, either to the service that is calling to say, oh, that this thing does not exist, right? We will never do that. But to the user, to the person who is in front of that laptop or phone who is doing that, we will fulfill that order. All right. If we are not sure that we have up to 20, depending on the business requirement, we will fulfill that order. We would make that order successful. Because if checkout is trying to reach out to inventory, this guy is looking for 5 pieces of this product, do you have it? And then inventory is down, checkout will not return an error to the order service or the payment service saying that, oh, I cannot do this. No, it won't do that. We will fulfill the order. But internally, by the time inventory is up, right, it would then update that record. Now, if that record doesn't exist, if we don't have up to, let's say, 5, that the customer wanted 5 and then we don't have 5, then that is an issue with the business, from the business team and the customer. We either do a refund or do something, or find an reach out to the customer and say, hey, what you wanted was not available. You never want to not take money from a customer. You want to keep the money first, and then if you can fulfill the order. You don't, in a business setting, you never want to have a situation where you don't receive money from the customer. No. Does that answer your question?
Yes, it does. Thank you.
Okay. Any other question? Any other question? Can we proceed? Can we proceed? Can we proceed? Can we proceed? You guys are going to love the next segment. Can we proceed? Yes. Can we proceed?
Yeah, I think we can proceed.
Omit, great. Okay.
Yes.
Now, guys, please pay attention to the question, to Jackson's question and Fonisu's question. We are going to switch now to the event-driven model so that we can see the difference. What's the name of it? I think it's called Git Checkout Events. I can't remember. Just give me a minute. Let me verify. Event branch. Okay, so we're doing Git Checkout Events. Git Checkout Event branch. At the end of this class, I'm going to give an assignment. It's a very tough assignment. It's a task that once you finish, it would propel you from wherever you are to the top 1% of developers. And the assignment is very hard, by the way. Okay. So we've switched. All right. Now, so let's go to the class notes. Good. Before we even come here, let's do this. Now, in a microservice architecture, maintaining data consistency among services can be challenging. Jackson, do you remember your question? Jackson, do you remember your question?
Yes.
Do you remember your question?
Yes, I do.
Right?
Yes.
Yes.
Good. Now, remember my answer to them. Maintaining data consistency among services can be challenging. The event-driven pattern provides a solution to this issue. In the event-driven pattern, services publish event when the state changes, right? If the product is created, the product will publish that event to a broker somewhere, and then other people will receive it. Other services subscribe to this event and update their state accordingly. This way, each service can maintain its consistency without the need for synchronous communication. Now, remember that all these calls were synchronous. All the calls we saw here were all synchronous communication. No, it's no longer here. Now, if the CAT service made a request to the product service, it wasn't asynchronous. It was synchronous because it would have to wait for a response, right? Because based on that response, it would then do something. We saw the code, right? Can you guys remember?
Yes, we did it.
Yes, we did.
So those were synchronous operation. What if to your point, what if the service takes it? Let's even say it wasn't down, right? Let's say it had network with connectivity issues because the latency issues. What if it would take less than more than a minute? What happens? The customer then has to wait, right? The customer will have to wait, and that's bad for us, right? Now, without the need for synchronous communication, this pattern enhances the decoupling between services and improves performance by enabling asynchronous communication. However, it can also make the system more complex and harder to understand due to the indirect nature of the interaction between services. Nevertheless, event-driven pattern is so powerful. It's a powerful tool for ensuring data consistency in the microservices architecture. Okay, let's go to the class. Why? Right? We know what it is. It helps decouples the system, assisting as it introduces the asynchronous nature to services. So why do we even need it? It helps with loose coupling, real-time responsiveness, fault tolerance. Now remember, if the business requirement if the focus of that requirement is fault tolerant, then we'll most likely use event driven, right? Event sourcing, the components of an event driven system. There's a producer. A producer is a service that does something. The message broker is the external service that receives that event. The event consumer is the other service that needs that information to do something, right? So let's look at the implementation with the RabbitMQ. Okay, we're going to go into all of this. Let me not waste the time of the class. Okay. So let's start with our first step. Now, who remembers what was the first step? Product creation. Product creation. Who remembers? All right. And I can't get a response. The first step was product question. Anybody remembers? Anybody? Okay. So let's start. To implement event-driven architecture in Laravel, there's a few things we need to do. Now remember, in the microservices architecture, 60% is configuration, 40% is code. Let me say that again. If you're considering migrating to a microservices architecture, remember that 60% is configuration, 40% is code. As a matter of fact, some people will argue is 80% configuration. There's a lot of things you need to do, interactions with services. In fact, I have seen a prediction that says that 80% will be configuration, 20% is code. Because with code, it's something that you're already doing every day. You get nothing will change. You are simply trying to decouple your services so that they can interact independently and be deployed independently. So let's start. For the purpose of this class, we're going to use RabbitMQ. RabbitMQ is a message broker, that allows for communication between services. It's open source. Okay, I'm just going to share how we did this. I encourage everyone to read about event-driven architecture and read about its implementation in Laravel. Okay, this is RabbitMQ. So we're using the free plan, maybe, and the free plan only allows for 1 message per month, right? Maximum connections. So we're using the free plan, but so once you get to cloud, cloud.ampq.com, you'll be able to get started. You create your free plan and then follow along. I'll share the steps as we progress. So this is what the dashboard looks like, right? Let me share. Okay, so once you get in, right? Once you get in and once you're able to register, you would see this page that lets you, like, the dashboard, right? Because it's a free plan, of course, we won't have access to a lot of things, but this is what is important. You would have your user and vhost, and then you have your details. This is the details we're going to use for the configuration. So this is step 1. Step 1 is registration with RabbitMQ. Step 2 is downloading a package called Vladimir. You know what? Don't worry. I don't have a tongue to break. This is the package. Why not use Kafka since there's limitation with RabbitMQ? Yes, we'll do Kafka. Don't worry, we're getting here. Oluwasegun, yeah. I'll share the experiences with Kafka. We will talk about Kafka, please. Oluwasegun, please remind me. Let's talk about Kafka in a minute. So you install that package. Now, with that package comes an additional configuration in the config. In your config directory in Laravel, you get to queue, right? So step 3, get to your queue.php in your config directory, and then you would paste this block of code. My battery, Benjamin. Okay, I pasted the code. The code will be on GitHub, so you won't even need to do this. Right now, what are we doing here? We are simply saying we are providing the connection detail for RabbitMQ, right? Simple. What you normally do for other things. Is step 3. Step 4 is to now get to your env and then specify the detail of RabbitMQ parameters. Now remember, the hope the recording will also be available. Yes, the recording will be available. So you see this detail, you see the login credentials here, right? That's where this is where it comes. This is where it comes. Good. So let's proceed. Now, because we have just one message, we are going to do a lot of tweaking. Now, what is the purpose of event-driven architecture? How do I do this? In the other architecture, every service had to make calls. Do you remember?
Yes.
If you did something, you would have to make a call. But with the event-driven architecture, that will no longer happen, as each service would have a copy of that data to independently verify that information. Does that make sense? Does that make sense? Now let's go back to the inventory. Now remember, now in the inventory service, the inventory needed to make a call to the product service to find out if the product exists before creating that inventory. But in the event-driven model, the inventory service has a record of products. So let's go. This is our event. This is our inventory category, inventory service, right? See, the inventory service has a products table. Can you see? Can we see? Right? The inventory has a products table. Now the inventory has the product. Of course, it will have, because it has a table, it will have the model. It has its own product model, right? The inventory has a product service. Now, pay attention. These teams may be sitting anywhere in the world, anywhere on the planet. The product team can be sitting in China. The inventory team can be sitting in Mozambique. The checkout team can be sitting in Nigeria. Anywhere in the world. What each teams would do is to say, so if let's say there's a few of us in the inventory service, we would send an email, of course, with the business meeting, would require the product service. Now remember, look at the product service. Look at the product service in the inventory service. It has just exist by ID. But the product service in the products, like the product service class in the inventory service, just has exist by ID. But if we look at the product service in the service itself, in the owner, it has a lot more, of course. Look at this product service. Now, this is the product service class in the product service, right? Product service class in the product service has a lot more things, right? But when that service needs to go in, when that service class needs to go into a different service entirely, it will not need everything. Does that make sense? It won't need everything. It will only need what that service needs. Look at the repository. Look at the product repository class in the inventory service. It just needs to save, update, find, get the price, and exist. In fact, it doesn't need all this. Okay, so let's go. Let's go back to the service. Let's go back to the inventory service. Can you guys remember that in this place, in the other model, we needed to make a call to the product service. Do you remember? Can you guys remember?
Yes.
There was a code
Yes.
to make a call to find out if the product exists. Okay. So how is event model? How is the event triggered in Laravel? So here's the first thing that I did. Please pay attention. It was tricky for me. The first thing that happens is that the service, the producer, now the producer is the one who produces an event, right? Does that work? It's how will produce a message. So the first thing that happens is that I created a job called product created, right? Step one is that I created a job called product created, and it just, all I'm doing is expecting the product in the constructor. Now remember that in the constructor defines the expectations of a class at the point of instantiation. Anybody who wants to use this class must provide the product object. If product created, product deleted, product updated. How did I do that? It was simple. PHP artisan make job product created. That's all. Created. That's if I can spell. Created. This all, right? Same thing, product deleted, product updated. That's how it was made. So this is the producer. So this is the source. Okay? This is the source. Now remember, there are three components: the source, the broker, and the consumer. Where the event is coming from, where we will save that event, and the people that will consume it. So this is the source. Step two is that I went to the inventory service, the service that needs to receive a change in that event, that needs to listen to it. I went there and created the same job, app jobs, product created. App job, products created. But in here, this is where the inventory service does the actual product creation. Does that make sense? Does that make sense? Here, I'm receiving the product as well, and then I have an instance of the product repository. Now remember that the product repository is now a version of the product repository is now domiciled in the inventory service. Look at it here. Remember, your repository just does everything that has to do with database interactions, right? So it's going to interact with this. So I'm receiving an instance of the product repository here and then saving it. Now, where will I get this from? Once I receive that product, the product object from the product service, I would retrieve the elements of that of the object and save them in the product table in the inventory service. So let's demonstrate very quickly. All right. Okay, so now this is the inventory service. So the first thing we are going to do now is that we are going to do PHP. Let's do PHP artisan Q flush. Let's flush all. Okay, PHP artisan optimize. Let's clear things out. This is the, now remember, we're trying to create a product, right? So we're going to do PHP artisan Q work. Okay. Once this happens, the inventory service is now listening for that event. Okay, so let's go to our now remember here we have configured, we've gotten details from our RabbitMQ, and then we have configured a Laravel application with it. This is the dashboard. This is the, this is where you have the graph. Now, one other very important thing is that this configuration, your RabbitMQ configuration, or Kafka, Apache Kafka, or any other thing, that configuration that I showed earlier would be the same for all services. All your services, config, your EMV, same RabbitMQ configuration will go on all your services, right? Does that work? Good. Now,
Yes.
now that we are done with the configuration, our inventory service is now ready to listen to an event, product created event. Okay. So let's go and create a product. Let me recap. For event, the source will create a job. The event, the service, the consumer will listen for that event. How does the source create a job? PHP artisan, name of the job. I forgot something very important. In the inventory service, in the consumer, in the service that is trying to listen to it, we are going to bind that this product created. Where is it? Providers, event service providers. Good. We are going to bind it. Please look at this. This is very important. So you see, I'm just binding that job, that product created class to the event in the inventory service. This is straight from Laravel. It's not this is not difficult. This is really easy. If you've done this kind of thing before, it should be familiar. This is what makes it work. If you don't bind that event to the application container, it won't work. Just creating the event here also will not make it work. Here you have the jobs, product created. Yes, that is true, but then we have to bind it. Please, does this make sense? Are we following? Are we following?
Yes.
Yeah, we are following.
Good. So let me recap. The product service is the producer who create a job called product created in the product service. That's the source. Then in the receiver, we'll create that same job and then bind that job class in the container, in the application container. Okay. Next step. So let's go and create. First of all, let's look at our products first. Let's look at our tables. Product service. Please pay attention to the products that are here. Alamo iPhone 7, right? Okay. The product table in the inventory service doesn't have iPhone 7 because we added iPhone 7 in the last model, right? I can't remember who gave us iPhone 7. So now, so you can see that there's just 1, 2. This is 1, 2, 1, 2, 4, 8, 7. So we have 1, 2, 3, 4, 5, 6, 7. In the product service, we have 1, 2, 3, 4, 5, 6, 7, 8. So let's remove this iPhone 7, right? So we're not confused, right? So we're going to remove iPhone 7 as well from here. Okay. Checkout. We're going to also remove everything that had to do with 31. I think it was 540. Here you go. Delete the row. Card item of 540 would go as well. All right, so we don't have any reference to iPhone 7. So we have 1, 2, 3, 4, 5, 6, 7 products. Please confirm that you can see. So we're going to create a product here, but we will also want to see if that product will also be here. Can you see? So the databases are the same. All right. Hopefully we can make this work. So we're going to create another product. We are down to 15 people. Okay. Hadizat give us a product. Hadizat give us a product. I'm sure she's not expecting that. Hadizat, please give us a product name. Hadizat, give us a product name. Hadizat.
Okay.
Hadizat's product name?
Pets.
Hadizat, product name?
Can you hear me? I said skirts.
Yes. What type of skirt?
High waist skirts.
High waist. Oh, high waist. Okay. Okay, so let's say the new Elizabeth Harden high waist. All right. How much is our high waist skirt? Hadizat?
22,000.
22K, 22,000. Great. Now, Ara star skirt. Okay, so we can create another one. Okay. But with Jackson, you have so much information. Okay. All right. What happened? I think I canceled the request by mistake. Good. Now the product has been created. Let's go and see what happened. Now, can you see that this is the inventory service? Can you see that the inventory service was able to listen to this product creation successfully? Please confirm, guys. Do a thumbs up, or
Yes.
and let us know that we're following. So let's go to Kafka. So can you see that this is when the Kafka received that event? Can you see?
Yes, we can see that.
Good. Now, so let's even go to our products, our inventory. High waist. Please pay attention to the product ID 32. Can you see this is can you see that it has been created here as well? Can we see?
Yeah, we can see that.
Inventory service. This is our inventory service. This high waist has also been created in the inventory service. So with event-driven architecture, whatever happens to that product, the services that are also listening for it will receive that event. Because remember, when they need it, they won't make a call. They won't need to make a synchronous call to that service. All they need to do is check their own record for that information. So what they're doing is independently verifying that what they need is available. If they don't have it from them, if they don't have that record, it means that that record does not exist. All right. So now that product has been created, let us go and create an inventory, okay, of the high waist skirts. Now, while we are there, let us look at the code. What is happening there? Inventory service. Inventory service. This is a long class. It's not for everybody. Trust me. It's for. I mean, upskilling is a tough job, man. It took me over 72 hours to put this little thing together. On line 27, let me increase this. On line 27, please confirm that you can see that this is where we are replacing the call to the product service. Now we are simply making that call an internal. So you see, it is now calling this method. Does inventory product exist? It called the exist by ID in the product repository. Where is this product repository? The product repository is now inside the inventory service. So you see, you're just calling exists. You're just calling exist by ID. This is what it's calling the service. It's calling exist by ID. So let us go and create. Let us go and create a. Let's go and create a. What are we creating? We want to create an inventory of the high-waist skirts, right? And then it's 32. Create inventory. Add inventory. If you have any question, please unmute your mic and ask. Don't wait till the end of the class. If you have any question, unmute your mic and ask. If you have any question, unmute your mic and ask. Hadizat has left the class. I wanted to ask how many skirts that we need, that we receive. Okay. Where's Jackson? Is Jackson still here? Jackson is not here. Okay, can another person help us, please?
We need
Quantity.
50 skirts.
50. My God.
Yes.
My God, that's a lot of skirts. Okay. All right, so let's do that. Hadizat, welcome back. We're looking for the skirt quantity. Now, please confirm that the creation of the inventory is still successful. Can you guys see?
Yes. Yes.
And if you notice, it was faster.
Yes.
It was faster because we didn't need to make a call to the product service to say, oh, please, we received the product ID of 32. Does it exist? And that one will do its thing and return a response saying, oh, yes, it exists. Okay. No, we didn't need to do that. It was faster. Now here's that code again. Here it is. Here. Where are you? Inventory. Where's create? Here, on line 27. This is where that was. This is where that happened. Okay. So, do we have any questions?
Okay, sir. So when an event is triggered, right, from a certain service, right, the other services listens to the event and acts accordingly.
Yeah.
Yeah. Is it possible that one event can be successful and the other in the background is not?
Is it possible that one event can be successful and the other is not? So
No, okay, not the event exactly, right? I mean the response to the event, right, from the service. Is it possible that one can be successful, right? Say the is it possible that one can be successful and then the other is not? Yeah, that's my question.
okay, so let me try and understand your question. There's the producer, there's the broker, and then there's the consumer. So at what point is it not successful?
Okay, so for instance, when we were creating the product, right? The event was triggered in the product service, and then it was listened to in the inventory service, and then the information about that particular product was stored there. So what if it is successful on the product side and then it is not successful on the inventory side, so that the information is not created there?
Good. So let us examine the some of the factors that might make that operation not successful. Remember that the event is triggered in the product service. That event that is triggered in the product service is sent to the broker over a network. You omitted that bit in your question. So there's the producer, there's the broker. Between the producer and the broker is the network. So as long as that event that was triggered has been received by the broker, the consumer on this side will receive it. So the only way that it won't be successful if the event has not been triggered. In other words, if the broker has not received it. Now remember, whether there is network or not, the product will be created. See, there are two things happening: the product creation and the creation trigger different things. If, let's say, if we turn off the internet for this for this PC now and create the product, it will get created, but our message broker will not receive that event. Does that make sense?
Yes,
Right?
yes, it does.
Good. So let's say the inventory service was in another cell, another cluster, maybe in Asia or somewhere. If the broker has it and there's connectivity on this other side between the broker and the consumer, then the consumer will not receive it. Right? So the only possibility is connectivity. But as for the event itself, as for the action itself, it will get created. Whether you receive it or it is a different question. But as long as the broker has that event, whoever is consuming will receive it. If they, of course, if there's no latency, if there are no network problems. Good question, by the way. Any other question? Tochukwu, Junu, God's time, question, or ask questions. Ayeni, question, observations, comments before we proceed. Questions, comments, questions and comments. Questions,
Well, not
comments.
from my end. None from
Okay.
my end at the moment.
Who else? Anybody? Questions, comments? Trust me, this is for upskilling. Is a tough job. It requires a lot of discipline. So I really appreciate those of you who are still here. Okay, can we proceed? Can we proceed to the next phase?
Yes, can proceed.
Good. So now, we are going to stop. We are going to stop this because it cannot be received at the same time. Okay. So let us stop the check. Let us stop the inventory service from listening. Where's the inventory service that was listening the first time? I need to stop the inventory service from listening. We want to make the checkout listen. Okay. All right. So we have stopped the inventory service from listening. So now let's make the checkout. That product, right, that has been created. So we've stopped it from listening. Okay. So let's PHP this queue work. Okay. So we're going to so you guys bear with me. If we create this product again, right? If we create this product again in the product service, it will be no, what was that? Highway skirt. If we create it again, it's going to be 32. Okay. So let's do it just so that the checkout will have that product. Does that make sense? So we're going to delete the product here. Remember, it is 32. We'll edit it again. 32. So we're going to create it again. Once we create it, right, the checkout will have a copy of that product as well. So let's create the product inventory. Now we want to create the product. So let's create this product again. This product has been created. Please confirm that you can see.
Yeah, we
Right,
can
the
see that.
checkout.
Yes, yes. we can see.
Good. The checkout has also received that event. So let's go to the checkout table. Can you see high waist? Can you guys see? Can you guys see?
Yeah, we
That the
can
high
see
waist
that.
is here.
Yeah.
Good, but we don't want it to be 33. It was 32. Now, ideally, we won't need to do this if we were on a higher plan, right? All the services will be listening in at the same time, right? All the services will be listening in at the same time, and then they will receive the product ID at the same time. Now, remember, please, very important. Once you are creating, once you're about to create the product table in the checkout service, the ID cannot be auto incremented. It will just be plain. Remember, it is receiving the product. It cannot come and create its own ID. Does that make sense? The ID will not be auto incremented. I'll put that in the detailed note. So that is 32 now. This is now 32, of course. In the inventory was 32. So let's make this 32. Right? So now, so we're assuming that both the checkout and the inventory were listening to the product creation event at the same time. Does that work? We have to do that manually because we can only do one. The connection is one. It's limited. Yes, Ghost time, please. Go ahead.
All right. So you said something.
Ghost time, go ahead.
You said, if you can you hear me? Can you hear me?
Can you speak
Can
up,
hear me,
please? Can you speak up? Yeah.
Okay.
Yes, we can
Confirm
hear
you could hear
you.
me, please.
Yes, we can hear you. I can hear you.
Yeah, it's better.
All right. So you said something. So you said if you create the products right from the product service, right?
Mm-hmm.
So you said if you create the product from the product service, right? And if you come to part service, right? That you don't need to increment the ID for the table.
Yes.
So
Yes.
I'm saying now, what if we have the ID as increment and have another column produced as product underscore ID in that product table? Does that work?
Sorry, do that again. Please take your question again.
So I'm saying that some seconds, right? Because I've been talking ever since. So, but I'll just go again, right? So, so if you're creating a product, right, and you're on the table, right? On the cart service, right, we have the product table. So you said that for that product table that's on the cart service, right? Let's say the cart database, right? That we should not have another ID, right? That's increment.
Auto increment.
Right. But I'm asking now. Yeah, what if we have product ID, like another column introduced as product underscore ID? Does that work?
Yes, it works. It will only work if you yes, it can only work if you engineer your new product model in all the other services to receive the product ID as the ID from the product table. It will work, but it can introduce
so in
a level.
Right, we have essence that instead of having the ID or something, instead of the product reference table across the different services, that is not the main product
Yes.
table. Yeah.
Yes, yes, you can have that, but you have to be careful to make the every piece of code that is looking for product ID to fetch the ID from your product underscore ID. Does that
sure.
work? Does that make sense? Yeah, because so the reason it is advisable to keep everything consistent across board is because you don't want to introduce an additional level of complexity. See, this approach is already so, oh my god, guys, I spent a lot of hours just putting together this simple thing because things began to fail. Initially, the plan was to do the gateway service, gateway pattern. I think that's it. In fact, if you look at the code, it's already there, right? But some things failed in between. So in microservices, you want to make your life as simple. You want to make your life as easy as possible. Believe me, I am on a microservices team on a live product, and I know what I'm telling you. You want to keep things as simple as possible, as documented as possible, as consistent as possible. Otherwise, it will make your life a living hell. Does that work? So the answer is you can, but it's advisable to keep things consistent across board. Does that make sense? Does that work? Ghost time, does that work?
Yeah, you work.
Ghost
Yeah.
time has gone to
he
fry
works. I just have to
plantain.
just
All right,
that
okay.
so that-
Yes. Okay.
it
So let's
works.
proceed now. So let's stop the checkout.
I just threw that other people will be away.
All right, okay, that's fine. So now in the checkout service, I was doing something. I'm happy you guys are here, so we can look at the so in the checkout service, right? In the checkout service, checkout service. Oh no, okay, yeah, checkout service here. Remember, the checkout service makes 3 calls: one to the product service, right? Another to the in fact, oh, I'm happy it's still here. Another to the product service. One to the product service to check if the product exists. Where is that? Here. Another to the inventory service to check on line 79 to get the quantity of that product. We are now at the checkout service now. And then another one to the product service to get the price. Okay, so here, once the inventory is created, after this, once we can resolve this, then we can close and schedule. Guys, what do you think? We can have another class in 2 weeks, 2 weeks from now, just to make up for last month.
Yes, please.
2 weeks, just so that it doesn't take that long anymore. 2 weeks from now is 2 weeks from now is 12th. Daniel, please take note. 12th of. I mean, if that's okay with everyone, so that it's so that it's close enough, so that we don't take that much time, so we don't forget. Does that work for everyone?
Yeah, I think that
works for me.
Yes, that.
Yes. Just to cover for the next one. Now, so 3 calls. The checkout service made 3 calls to 2 calls to the product service and 1 to the inventory service. Okay. So let us do 1, and then we can close because of time. So replaces the call. Good. So let's go through that process. Now, who will now be the producer in this case? Does inventory? We already have this. We already have the product. The product exists because we've created that product. We created that skirt. Now remember, that high waist is now in the checkout service. Now look at it here. The high waist of product ID 2 is here. Is also here. You can see high. So We've done that already, right? Remember, if like that, the product creation for the checkout service was successful. I demonstrated it now. Right, the checkout was able to listen to that event and it was successful. Even though it was 33, we had to change it, go back and change to 32. Remember, so this is done. Now, what was the next thing? To add to cart, it checks if the product exists. It calls this method. Good. In this method, the call to the product service has now been replaced. So this is fine. So we can close it. The next thing, it calculates the total price for each product in the cart. Okay, let's get there. Calculate total price for each product. Good, this is it. Right? Product price. And then, but before we even do all that, let us even go and try and create the event. For this to happen, where is this? Okay, we're trying to add at this point. We're trying to add to carts. That's where we are, guys. In case you're confused, what's going on? We want to add to carts. So we want to replace all the calls to services or events. Okay, so if you check that, calculate total amount of the products. Let's do. Okay, where is that? Here, we're making a call to the product service. Okay. Calculate total amount in cart. Calculate total amount in cart. Okay, does inventory exists? All right. So does inventory exist? Where did we use that? Okay. So guys, let us do one thing and then we close. This product, this method here, check if product exists and get quantity from request. In this method, in our last implementation, there was a call here to the inventory service. Inventory. Is it inventory? Get quantity, the products, yes. I'm looking for the call to the inventory service. Yes, this is it. Check if requested quantity is less than or equal to available quantity. So this call was to the inventory service. This is what we're going to do this night, and then we close. The method, check if requested quantity is less than or equal to available quantity, is what we want to do now, and then we close. The line in question is line 79, where previously in our previous implementation, there was a call here to the inventory service to get the product, to get the quantity of each product. So let me show you. This is the inventory. Good. So you see that for each product ID, there's a quantity. For each product, there's a quantity. Basically saying, for this product, we receive 50 pieces. For this product, we receive 10 pieces from the supplier. Good. This is the method that checks that. Here, we are saying that here there was a call to the inventory service, but we are not doing that anymore. So let us practice our event-driven thing. So now, since this was a call to the inventory service, the checkout service needs a record. It needs this same record. See this record. The checkout service needs it as well. Right? That is, remember, that is the only way it does not make a call to the inventory service. Because it has its own copy, so it will simply reach out to its own database and retrieve that information. All right. Are you guys here? I know.
Yes, we're still here.
Okay. So the inventory. So the first thing that happens, remember, is that the producer creates a job. So this is it, right? It's simple. Remember the remember it's simple. Let me do it again. PHP artisan make job inventory created. Once I hit this, it will tell me that it has already been created. But I wanted to show you the command. Job already exists, right? In the job, the only thing we are doing is expect an inventory object. That's all we are doing. Remember, we are at the producer level now. Okay. That's all that the producer needs to do. Now, the person who needs it, the service that needs it, will now come here and do the same thing. App jobs inventory created. Okay, so let's do the same thing. Let's go there. CD CD checkout dash service. All right. PHP artisan make job inventory created. Once I hit this, it should tell me that the job already exists. Job already exists. Job, great. Now, because this is it, all right? Okay. So here in the consumer, what are we doing? We'll supply the inventory object that came from that the producer is expecting. Let me put this side by side, the job side by side, so we can see inventory created. This is from the producer. This is the job from the consumer. This is the job from now. In the consumer, what are we doing here? It's simple. We are making a reference, creating an object of the inventory repository. Now the inventory repository now is now domiciled in the checkout service. Let's go there and find out. See our inventory repository. Now remember what I said. The service that does not own a repository will only have the methods that it needs. It's not trying to do everything, right? So now it just needs to save, find by product, update, and exist. That's all. So please confirm that you can see that the inventory repository is inside the checkout service now.
Yeah, we can see that.
Good. So now in the checkout service, now the checkout service is the consumer, right? We're now creating, once it receives that object from the broker, the broker will send it the inventory object. It will receive the inventory object and create that inventory. So you guys, this is the bug I had before the class. So maybe you guys can help sort it out. All right. Can you see? Then in the checkout service, in the consumer now, that's the person who is expecting it, we will go and bind that job to the service container. So you go to providers, event service provider, and do the same thing. Simple. Can you see? The first thing I expect, I import it, right? Inventory created, remember. And then here, I'm just binding. Let's take out these logs. I did this so that we'll see what is happening. Here, I'm just binding the class, the job, to the service container. This is straight out from Laravel. Okay. Do you recognize this? Anybody recognize this? All right.
Yes, yes.
That's all we need to do. That's all. Of course, remember all our services have the RabbitMQ configuration. So now let us go and make So who is going to be listening? Who knows who is listening this time? Who is going to be listening between the inventory and the checkout? Who is listening?
The inventory service.
The inventory service.
Inventory is list. No, inventory is not listening. Inventory is not listening. Okay, so let's go. Let's go back. We are in the checkout service now, right? The cart service, right? Previously, to add to cart, to be able to add to cart calls a method called check if. It calls a method called check if product is no. Yeah, look at check if requested quantity is less than or equal to available quantity. Because when you're about to add to cart now, what if the quantity you're looking for doesn't, like, we don't have it, or it's less than what we have, or it's more than what we have, right? So usually here there was a call here to the inventory service to say, oh, this customer is looking for 5 pieces of skirts. Do we have up to 5? We need to have more than 5 or exactly 5. Does that make sense?
Yes.
Good. That is why here we're saying that this call, once you get the quantity that we have that is coming externally has to be more than or equal to the quantity that they are requesting for. Does that make sense?
Yes.
Good. So now the cart service or the checkout service needs its own copy of the inventory. See this inventory. See this inventory here. The checkout service, this checkout service needs its own copy, so that when it's time to make that call, it will not bother trying to reach out to the inventory service to say, oh, hey, do you have up to 5 pieces of this skirt? This guy needs 5. Do we have up to 5? Doesn't need to do that. That's why it needs its own copy to independently make that assessment, right? So to be able to do this, the inventory in this instance will be the producer, so that anytime you create an inventory, the checkout service will also have a copy of that inventory. Does that make sense? Does that work? Does that work?
Yes.
Good. So now the inventory is the producer and the checkout is the consumer. All right. So okay. So we are going to do in the checkout service, we are going to listen to it, right? We're going to listen for that event. So we're going to do PHP artisan queue. Let's flush it first, right? It's usually a good practice to flush this. Okay. And then let's listen to it. Now it is listening. Okay. Now it is listening. So let's go and create. Where is our I don't know if I had this at here. Great, we had this at still here. Add inventory. Now remember, we had added inventory. And it was 50 pieces. Who remembers? I think it was Jackson.
Yeah,
who
I
gave us.
remember.
Good. So now we're going to delete it. Okay, let's try and delete it. Where is it? It's 32. Okay, let's delete it. Now remember, what we're trying to do now is create that inventory, and once we create it, our checkout will have a copy. So let's delete it and do it again. All right. Now, this is where I had an error before the class, so maybe we can sort it out together. Once I create it, boom, it gets created, right? The checkout says checkout says it's done, right? So let's go and check. Let's go and check the inventory. Refresh again. The inventory, but it's not here. So I would like for everyone to unmute their mics and then participate in this debugging process. I actually like this part of the class. So what happened? What happened? So first of all, let us go and be sure that the basic steps of debugging, let us be sure that the inventory had even sent that object. Step one, please, can everybody unmute their mics? Let's participate, please. This is debugging. We've seen that it has failed in front of all of us. It has failed. So let's find a solution. Please unmute your mics, please. Step one, let us go and be sure that the inventory had sent what it was meant to send. Please unmute your mics. God's time, Juno, Kevin, Hadizat, Daniel, Foniso, and the rest. Unmute your mics, please. Unmute your mics. Let's debug together. Now, see, I had placed a log. I had placed a log in the service, in the inventory part, to be sure that it is sending what it is sending. So let's go and confirm the inventory. The ID now is 25. Can you see 25? Please unmute your mics. Funny, so unmute your mic. God's time, unmute your mic. Hadizat and the rest is 25. So we can see that the inventory is sending. Look at it here, 25. The inventory is sending that data, right? This is it.
Yeah.
Right? Dispatch the inventory. So let's go and even confirm. Let me show you where that happened. Inventory service app. Where is that app? My laptop is shocking me. Okay. App providers, event service provider. So this is it. No. Inventory. Inventory is not doing anything. And the inventory placed the job. Inventory created. Inventory created. If you see something, unmute your mic and say it. This is the inventory. Dispatch the inventory. Okay, at the point of dispatching, right? Now remember, I don't know why I forgot that. This is where the inventory dispatches that event. Look at it. Please, everyone pay attention. This is important. When we are creating that event on line 31, we dispatched. We are dispatching the event on line 33. The event object that has been created is on line 31. Can you see?
Yeah.
Good. This is very important. If this does not happen, nobody receives anything. So we can see that the event was dispatched. At least the log had shown that. So inventory created, dispatch, you give it the object. I'm just converting it to an array because it's easier to work with that way. So we can see that the inventory has sent out what, as per the agreement, the inventory has done its part of the, has kept its part of the agreement. That's slow. So let's go to the log again and confirm, just to be sure. So you can see dispatch the event. Product ID has sent it. So what is the problem? Let us do this together. So in the inventory side of things, things are working as they should. So let's go to the checkout of things. All right. In the checkout needs let's go to the event in the checkout. Providers, event service providers first. Are we receiving the event here? Yes, we are. This is the event inventory created. We are receiving it here as usual, right? This is how it is. We're not doing anything different. But let's go to the log of the story. So you see, it's saying error creating inventory. Field ID doesn't have default value. Insert into inventory. So you see, where's the guy that asked question about Ghost time? Ghost time. Is that Ghost time? Was it Ghost time who asked a question about product ID?
It was Ghost time.
Right. So this is this is where Ghost time's concern may be. This is the use case where it says that use case is allow the ID to function as usual. Have another column in the checkout side that says inventory ID, because you can see here that the inventory you can see that the ID has been passed.
Yeah.
You can see that the ID has been passed. Guys, you can see
Yes. Yes.
ID has been passed here, right? But somehow it is not. So let's go and find out what could be the problem. The job. Let's get to the job. So you see, the ID is here now. The ID is here.
I think it's guarded. I think we have to add guarded on the model.
Say that again. I think it said something about guarded. Let's go and be sure. Inventory. Right. So good question. See why that is important. So we should be able to solve that problem now. Can you see what the problem was?
Yes.
Now what I will do for the sake of I will just do this, right? I'll just do this, but this is not safe in some cases. So, but if you want to explicitly mention the fields, then you have to mention everything. So let's do this. Good observation, Ghost time. Ghost time. So let's. Okay. My system is dragging. So let's restart the process. This should work now. Okay, so let's flush. Let's flush it. Flush. It's important to make practice to flush your. Let's listen again, and then go back to our database and can we? I like to take permission to delete this cat.
Yes.
Can we do
Yes.
that? All right.
Yes.
Okay.
Yes.
Good. Now that we have that, the inventory. Good. So let's create it again. Let's create it. It should be 25 now. It should be 25. Okay. Hopefully this works. If this works, then our class has gracefully come to an end. Fingers crossed. Boom. It's created. Yes, it's created. And our event is successful. Let's go to our inventory table here. All right, you can see that the same inventory 26, right, is here as well. 26, right? So now that the checkout service has its own copy of that record, it can do anything it wants to do. Right? Okay. Thank you so much, God's time, for the observation with the with the model class. That was really good. Okay, questions, comments, contributions, questions. It's time to talk. It's time to talk. Questions, comments, contributions, questions. So we have successfully seen how the event-driven architecture works and why it is important, and in fact, even it's speedy.
Yeah, I think the class was quite wonderful, but there's something I don't totally understand. Is every service going to have like a copy, like an exact database this is model, or is just going to have the ones that they need?
Good question. So let's get back. Good question. Do we understand his question? Should I repeat? He's asking, in the event-driven model, would every service have the same database schema, or they only have the fields that they need? Okay. Now, the checkout service. Let's go to the checkout service. The checkout service would need to make a call, usually, to the inventory service to find out if they have the quantity that the user is asking for, right? Now, in that model, in the inventory model, that is just a call to find out if that product is equal to or greater than what the user is looking for. So it's get product quantity, for instance. Where's the update product is by ID now? It's, look, there you go. Find product quantity. Once you give the product ID, it is going to go and check the quantity and return that quantity to you. Now, in this service, for instance, the checkout service just needs to know about the quantity. It doesn't even need, where's the inventory repository? This is the inventory repository in the checkout service. Remember, this inventory repository is inside the checkout service. It doesn't need all this one. It needs the save to be able to receive the inventory. It needs to find out the product quantity, and that is all. I think also updates the product quantity. Exists by product. So these are the methods it needs. For the schema, the tables has to be the same. Because remember, it has to be the replica of the table in the other services. It cannot differ, but the services can be different. The specific methods is looking for can be different. So if the original repository had, let's say, 30 methods, the checkout service will not need 30 methods. It will just need the method that it requires. Does that answer your question?
Yes, it does. It does. Thank you.
Okay. Any other person? Very poor. Paulinus, please, your question or comment.
Hello guys. Good evening. It's actually nice that we are having this kind of sessions, though I joined late because I was in another meeting. But then I just want to say something now. With the event-driven pattern, can't we have something like a central DB that all the services are connected to, instead of maintaining a replica of all of the same data on all data points or on all individual application level? For example, let's say I did not really follow throughout, just this last part. That's what I'm asking the question for. Why can't we have like a central DB? Because I have something that is currently in production that is somewhat semi a service worker. Like I have like a a load balancer that is
Mhm.
communicating with multiple app servers
Mhm.
and routing the network for all these applications. So
Mhm.
the way mine is configured, I have like a central DB that all of them are connected to. I have like a separate DB server. I have a separate cache server, and I also have like a separate file server. Like anything that is shared, I just separate them to a server that they are just individual servers scattered across. Then all application servers hosting a specific portion of the application connects to these things, and they communicate through like a broker service, the RabbitMQ, something like this. So I would just want to know why they are having the same replica of the database. Why not just have it on the central store?
Good question. Now, so you see, I wish we can record. I don't know if that this is a brilliant question. We as developers, we're not paid to write code. We are paid to bring solutions. And our solutions would be different depending on the business. First of all, the business case, the business requirement, and then the expected future, right? The requirements of the in a foreseeable future. So let me explain what I mean. Your solution works now, but if for some reason we like the service you're offering, right? And like we say in Nigeria, it has blown, and all of a sudden you are getting 50,000 users. Your app is growing like 50,000 users in a week. Every week you are getting 50,000 users. The whole team will now have to sit down and redesign the architecture. Pauline, do you understand? Pauline,
Sure, I do.
So what determines what architecture we're using per time is first what the business requirement is, and where we expect based on user growth, where we expect our user base to be in, say, 2 years, 3 years, or 5 years. Why you want to do this is if you expect 2 billion users. Now remember that the event microservices in itself is a subdomain of distributed computing. So with distributed computing, you want to place the database cluster close to the customers. So if you have users in Asia, the cluster has to be somewhere in Japan or China or Singapore, right? So that the users in Asia will not have to, the data will not come all the way from Europe, right, and travel thousands of miles just to get to the browsers, the users' clients, right, phones or browsers, right? So if you had millions and millions of users, the best thing, in fact, the standard practice is to have replicas. In fact, there are different. I love this question. There are different domains of persistence, right? You have the checkout service in China, checkout service in Japan, checkout, right? Because you don't want the checkout service to be in a central place and someone is trying to check out in Nigeria, for instance, and then data has to travel. Remember, in distributed computing, 5 seconds is an eternity. Yes. Does that make sense? Do you understand what I'm saying? What I'm saying is that your solution works for your current business requirements, current user base, and for point 2, the current distribution of users. So if you had 100 users, for instance, currently, and then your 100 users are scattered everywhere, then you might use a little bit of both, right? Distributed and then part of what you're doing. But then if you have millions of users and then your users are scattered all across the globe, then you cannot do that. Do you understand? The standard practice is to have a cluster close to the customer. That is why in some countries you cannot take EU data and put it in Asia. They won't allow that to happen. Right? You cannot take African, even though we don't have laws here anyway. But ideally, your customers' data will have to be close to them. That is why, if you remember, anytime you are choosing, you want to do provisioning somewhere, they will ask you to choose a cluster that is close to you. Any on DigitalOcean or AWS. Who knows? Who remembers what I'm talking about? Who knows what I'm talking about?
Sure, sure. That is something. I actually understand you. So I understand you, and the answer is really clear. But then the issue is this now. Now, even in a distributed service, whereby, for example, now you have like different portions of your application. Now you can have a data center. Let's say, let's use DigitalOcean for example. You have New York 1, New York 2, and New York 3, for example.
Yeah.
Now, for your users that are connecting from Northern and Southern America, you can say you are using New York 3 for those, and then you are using the Singapore. I think SON. I cannot really remember. You can use Singapore. Now, the thing is, you can have like your different services communicate with each other via a VPC. Like maybe you have like maybe you have like your microservice architecture hosted on Singapore for your Asian users, but then all these different components that are hosted in the Asia data center are communicating with each other through a VPC. Through a VPC with a shared database on that particular data center. Then you have like your distributed service hosted in another data center, let's say New York 3, that is serving your Northern and American users. Yeah, something like that. So this is what I'm asking. Though we can have like exact same database schema for different data centers, but the question is the smaller chunks of the applications, the different services that make up the microservices for that particular region, why can't they share like the same database? That's the question actually.
Good. So they can. You see, one thing that is important about your question and why I love it is that it exposes the true nature of the distributed architecture, right? Distributed computing. With distributed computing, everybody has to sit down and consider what works given the current user distribution, given the current resources like cash, money, right, the resources of the company, and then given the current technical requirements of the team, the technical capabilities of the team. Three things: current user base.
Also, the project budgets, how much the person gets. That's very important too.
Good. So architecture is not a science. It's an art. It's an art embedded in science. So if you try a model, once you try a model, you have to wait for your customer's response. Is it faster? Did they like it? Did they get the response? If not, then you switch. So we are always at every point in time choosing a direction that serves us and serves our customers the most. Does that make sense?
Sure, it does.
Yeah.
Right. So there's no, you can't say, oh, my way is better than your way. No. The customers, my own customers are different from your customers. My customer base is different from yours. The customer distribution, please, this is very important. Distribution of customers on the planet, a major consideration. Okay, Haliru, I saw your hand, and then I think I saw one other hand. Let's take time. Yeah, Haliru first.
Okay, thank you very much. Good evening, everyone.
Yeah.
I only wanted to contribute to the last question. So,
Right.
I think a reason why you might need a distributed database attached to to a separate database for each of the microservices is because you might want to separate concerns. Different teams working on different things might have need for different type of database. Some might want SQL database, others might want document-based database.
Absolutely.
So, depending on the kind of caching system, indexing system, and the speed and the kind of items that you're documenting or you're saving in your storage, you might want different needs. And some might decide, I like this type of database. Others will say, we want this. So there should be separation of needs. And if a different team comes to take over a different part of the system, probably a new microservice, you should not be forced to pick a technology. And you can try to do whatever it is you want, host whatever it is you want, create multiple replicas without caring about the other part of the team. I think that's just my suggestion. Thank you very much.
This is so beautiful. Haliru, you have opened Pandora's box. Paulinus, are you still on the call? Paulinus, unmute your mic.
Yeah, I'm on the call actually.
Good question. So let me tell you, the call is ending. The class is ending. My goodness. Let me tell you something that happened. So you see, on the business team, the business people are not thinking, like the thinking is different. Okay. The business people are thinking about the money quickly. See, if you've ever had an interface with people who are strictly business people who have to interact with the development team, they're going to realize that they don't care about your technology. They don't care whether they don't know what they're talking about. They have a business requirement, and the business requirement is this: we want checkout to be less than 1 second. If it's 1 second is a problem, in that case, we now have to sit down and say, okay, business requirement is checkout cannot be up to 1 second. What database do you think we are going to use? Would it be a relational database or a document database? Anyone? Relational or document?
Well, if I am the one working on such functionality, the choice of database, I believe, is not going to be my problem. Like, okay, wait, hold on. I understand you. I want to get to your point. Now, the reason being that depending on the product requirement. For example, now if it's something that we have a card, you have linked a card before and you are checking out, so we can actually charge that card. For such an architecture, I can simply just collect your checkout data, pass it to a job will process it asynchronously and get it done. I can even process it with like 21 milliseconds. Like within 20 to 21 milliseconds, your response is back. So it depends actually on the flow or how the business requirement is. In terms of DB, I don't think DB should like play, even though you have like 10,000 concurrent requests. You can also set up parallel scaling, whereby you have like a balancer sending your managing your request and distributing it according to. You can set up there are endless possibilities actually. The DB is actually the problem. Whether documents or relational, it's not actually a problem. Even though it's relational database, like depending on how your indexes are set up, it can still be like really fast, even though you are persisting it. Like,
good point. So we have raised several issues, right? And I'm happy that you've taken us in a direction. So out of the box, document databases are faster than relational databases.
Sure thing.
Without any form of indexing, just by their structure, by purely structure, out of the box, right?
Yeah.
We were speaking to Haliru's point where he said that teams should have the flexibility to choose what they need to do depending on what that service requires. So he was speaking to a point to say, you know what, it is better to have different services and maintain their, not just their databases, but copies of what they need to do. Because now, okay, let me show you something. Because for instance, this checkout service, for instance, is now looking for the product quantity. It can want to do something else that is not, that the inventory doesn't have, the inventory repository doesn't have. This is the inventory repository in the checkout service. The inventory repository in the actual inventory service has more methods. We saw that. But guess what? Another time, the checkout service might want to do something in this, from this inventory repository, that the inventory repository itself doesn't have. What happens then? So it's safer and easier for them to have their own copy of, you know, what they need, right? And here's the caveat: as long as that copy will be updated every time, you know, every time it changes from the source, in this case, the inventory service. So great point, Paulinus. In fact, because of this point, I think that we should have this class every two weeks. I mean, if that's okay with the class. Okay. Any other contribution or questions so we can close and let people go? It's to 11.
Okay, yeah, thank you. I think Ghost Time, did you as your concerns? Okay,
Ghost Time is no longer with, oh, he is.
Okay, Ghost Time raised his hand. Yeah, you can go on.
All right, so I just have
Ghost Time, please.
Right. Okay. All right. Yeah, so I just have some contributions to make, right? So yeah, thank you very much for this second, right? I know it's very difficult for one to explain explain what's called microservice, right? In this so thank you very much for that. I do appreciate. So I also want to mention that you also understand that microservice is expensive, and I won't also start to microservice way because it's expensive, right? And somebody raised a concern that why would you have to use multi-database, right? For these services, right? You can't do this. Yes, you can actually use one to achieve it, right? But then, right? I think raise them. Right? People try to use multiple databases for their use case, you know. So one of the can you hear me? Are you still using multi-databases?
Yeah,
you can hear.
Yeah. Okay, so one of the benefits of using multi-databases is that if your database gets hacked, so let's say database A gets hacked, right? You can easily spin up that database with data from other databases, since you have the replica on other databases, right? And also another benefit of
security.
Another benefit of using database when we feel so it feels doesn't affect other part of the applications. And also I also worked in a fintech company where we do heavy database queries, right? Sometimes that
Okay.
This we have different trying to make these queries and sort out that will just get low. Right. We to the server and try to free it up, right? But in that case, I think if we are using microservice, we have to put more pressure to be
okay.
Yeah.
So Ghost Time, your point is brilliant, but we lost you, intermittently, right? Well, if you can, end your thoughts in the group, it will help us engage at the group level. But Paulinus wants to respond. Paulinus.
Okay. So the point you raise is very very valid, and it's very important that we take application security and data security really seriously. But now, in as much as it is like it's a good point, it's a good point to like it's a good thing to have a replica of your DB in multiple on all your microservices, all the different chunks of your microservices. But now, one thing is this. This is an issue that can be fixed. This is an issue that can be fixed because okay, with let's say we are all Laravel developers, most of us actually. Now, if you are coming to the Laravel ecosystem, we have like Forge. We have Forge. Now, with Forge, we can quickly spin up a database server. Let's say we have a database server of like 8 gig RAM, 160 gig SSD, and let's say 4 vCPUs. Now, with this server can handle every 30 minutes backup. Like you can set up your backup frequency to every 30 minutes, down to the minute if you really want to do so. Now, which means you are having a copy of your database like every 5 minutes, every 10 minutes. I don't know if you get me. You have like a good backup, and a good practice to always store your backup in a separate data center, a separate data center. So you can easily set up your S3, or even DigitalOcean Spaces to like quickly back this your data up. You can even set up a custom server that you want to push this out to. So I don't think security is like it's a reason to do it, but then it's not really the only way for us to go about it. I'm actually really against the fact against the point of having the same DB all over everywhere. You can have your microservice architecture. Like I told you before, I have my fraud detection system. I work for a fintech that we process transactions. Now, we have our fraud detection system like hosted on a different platform. Separate service on its own. We have like our core transaction processing engine all written in Laravel, like on a separate platform. Now, what happens? Whatever you do, any action you take, the core will always pick up the actions you take, you make on the platform, and send it to the fraud detection system. It will calculate your risk factor and see if this person poses any threats to us. If we see that okay, there are some behaviors that we have noticed that people that are involved in these criminal activities they actually do. Once we see those kind of sequences, the fraud detection system will flag that person automatically and send like a request to the other. Most of our architecture we communicate via HTTP mostly, but sometimes we use RabbitMQ to broker our messages as well. So it will communicate to the other one that this person has a risk factor of 90. We are putting your account PND ASAP.
Put no debit here.
Your account moves to PND ASAP. If it is a mistake that this happen, once you log in back, you will see that see what is happening. You can contact us. We will review your issue. Then, if it is a mistake, then we can actually like reactivate your account, remove the PND state. So now, all these service that I'm talking about now is only the fraud detection system. It has its own database that is separated from the main database. Does not have exact replica. I don't know if you get me. So I'm against the fact that every service will have the replica of the another services database. They should have their own database if need be. But if all of them they are communicating together for a specific purpose, like you have like different replicas of your fraud detections and all that, let them communicate to the same DB. It is very, very vital because I know what I'm saying. There were things that I met with when I was coming up with the architecture I'm using right now. So there are a lot of things to consider actually.
Good. Get what we're going to do, right? We're going to go and I'm going to post a question, right? I'll post a question now after this call, and then we'll respond. Those of us that were in the group here, priority will be given to those the people that were in the class. Will respond with, where you are, right? Are you for same replica in all the services, and then you state your reasons. Are you against it? Are you state your reasons so that way we can engage on the group? Does that work? Of course.
That works.
Thank you so much, Paulinus. It was great. Thank you so much, God's Time. Thank you so much, Junua, Hiliru, and all the rest. Daniel, over to you.
All right, thank you very much. Thank you so much, everyone. Like, this is more than 2 hours. This is 2 hours, 30 minutes, and some of you stood by, till this time. I really appreciate you guys. Thank you for joining today's session. We're definitely going to do this again in the next 2 weeks. We'll drop update. 32 minutes. So that's 2 hours, 32 minutes. So we'll definitely drop updates on that. And yeah, this call was recorded as well. So we'll also try to send the recording across so that everyone could also watch it in case you missed out on anything. I want to thank everyone for your contribution. Thank you, Mr. Nelson. Thank you, God's Time. Thank you, Mr. Hamza. Thank you, Paulinus. Thank you to everyone, Hadizat, and everyone who stood by. Kevin, Mfoniso. I really appreciate you guys. And see you soon. Have a great night. Tomorrow is Monday.
I swear. All right. Thank you guys for having us. This was so insightful.
Yes, definitely.